Hello, my little mathematicians. Today I'm going to help you finish your study guide for Mod 6 through 8 on ratios, rates, and percents. So let's go ahead and take a look. Okay, so for the first one, it says write 3/5 as a percent. There's several ways that we can do this. And since this is a study guide, I strongly recommend that you try them yourself, pause the video, try it, and then unpause it and check to see how you did. Okay. Now, if you did it a different way than me, as long as you get to the same answer, that's fine. One way you can do it is here's the fraction, 3/5, right? And if they want it as a percent, percent is always out of 100. So if I can figure out what this number is over 100, whatever this is the percent. Well, can you get 5 to become 100? Yeah, if you just multiply by 20, right? So 3 times 20 is 60. So that means that this is equal to 60%. Okay, that's one way that you can do it. An easier way, if a calculator is allowed, is to take this fraction, change it to a decimal by going top divided by the bottom. So type in 3 divided by 5, and you'll see you get 0.6 in the calculator. And any decimal can get changed to a percent if you just multiply it by 100. Essentially what you're doing is you're moving the decimal 2 places. So I remember this helpful little phrase dip, DIP. If you're going from decimal to percent, move it 1, 2 to the right. If you were going percent to decimal, you'd move it 1, 2 to the left. Okay, so start at decimal. To move towards percent, go 1, 2 to the right. So we need a 0 placement holder. Look at that, 60%. So no matter what, if you liked to do dip or if you like to just know what it is over 100, either one of these ways will work to get you that it's 60%. Okay, number 12 says 48 is what percent of 70? If necessary, round your answer to the nearest tenth. Okay, and that only applies like if it keeps going and going and going. Remember this helpful little phrase of is over of equals percent over 100. Okay, so 48 is, so it goes in the is spot. What percent? So we don't know the percent. So the percent slot is the we don't know. This is always just 100. And then it says of 70. So 70 is the of. Now that I have this, can 70 times something equal 100? No. So let's do cross products. So 70 is across from x. And those get multiplied together. Set that equal to 48, which is across from 100. Well, 48 times 100 is 4,800. And then to get x by itself, I want to get rid of this 70. And since they're being multiplied, the opposite of multiplying is to divide by 70. So that those cancel. Anything divided by itself is 1. So you have 1 times x, which is just x. Great, I got x by itself. I can do that as long as I divide the other side by 70 as well. So for 4,800 divided by 70, if you type that in, you get 68 point, let's see, 4,800 divided by 70, 68.571. It keeps going and going. So if I want to round it to the 10th, well, that 7 tells the 5 to what? Go up or stay? If the number behind the one you're focusing on is 5 or above, then this would go up to a 6. If the number right here was 4 or below, then it would tell this to stay a 5. So since it falls into the 5 or above category, this 7 tells the 5 to go up to a 6. So it's 68.6%. There we go. Okay, number 13 says 39 is, so again, we're going to use that is over of equals percent over 100. And if you haven't paused the video yet to try it yourself, please make sure you try it before we go through it together. See if you put them in the right spots. Okay, so 39 is what percent, so we don't know the percent, of 90. And that's always 100 right there. Okay, well, you can't go 90 times something to get 100, so let's do cross products. So 90 times x is equal to 39 is across from 100. And I can simplify that. 39 times 100 is 3,900. And to get x by itself, you want to divide both sides by 90. So those cancel, and you get 1x equals, well, 3,900 divided by 90 is, let's see, 43.3 going on forever, right? Or sometimes you might see that as 43.3 with a line above it. Both of those mean 43.3 repeating. And if it says it keeps going on and on forever, you want to round it to the 10th. Well, that 3 tells this 3 to stay as 3. So it's 43.3, and we were solving for the percent. So it's 43.3%. Okay, I'm going to change colors just because it's all blending into this box. Number 14 says solve for n, and you have 25 over n equals 5 over 8. Well, cross products, 5 is across from n, and 8 is across from 25. And if you type in 8 times 25, you get 200. And to get n by itself, I want to get rid of that 5. So I'm going to divide both sides by 5. Those cancel, and you get n equals, well, 5 goes into 24 times, tack on the 0, so n is 40. Do I put the percent? No, because I wasn't solving for the percent. It's just right here. Okay, so that is one way I could have done this one, but this one also could have been done with a shortcut. Because look, if you go towards your unknown, 5 times what is 25? 5. So then 8 times 5 is 40. So whether each way you did it, as long as you show your work, it's fine. And again, always go towards the unknown. So this one here, because you could have gone 25 divided by 5, but you don't want to go this way. You want to go this way. So that's why we did times 5. Okay. As long as you got 40 as your answer, it doesn't matter which way you did it. This way sometimes works, but cross products always works. Number 15 says use cross products to solve the proportion. Again, cross products always works. That's why we suggest it. But if you can do the shortcut, why not? Can we do the shortcut this time? Is it 5 times 3? Well, yes, 5 times 3 is 15. But remember, we always want to go towards the unknown. So I actually want to go this way. So it's 15 divided by 3 to get 5. So it's 9 divided by 3 to get me this 3. And that's why sometimes we say maybe cross products is easier, because it just takes away that chance that you could have accidentally gone, oh, times 3, so 9 times 3 is 27, when the correct answer should have been 3, because you need to go this way and divide by 3, not multiply by 3. Versus if you had just done cross products, 15 times m is 15m, 9 times 5 is 45, and then to get m by itself, you would divide by 15. Those cancel, and you get m is, well, 45 divided by 15 is 3. So some people just like this because then they have less of a chance of accidentally making that mistake there. But if you're good at always going towards your unknown, sure, do the shortcut when it's possible. Okay, number 16 says John Summer Baseball League has 36 13-year-olds and 48 14-year-olds. Write the ratio of, okay, when they say blank to blank, it matters. They want it in that order. So we want 13-year-olds on top and 14-year-olds on the bottom. So how many 13-year-olds were they? There were 36, and there were 48 14-year-olds. And then when they say they want the ratio, I want to reduce this to lowest, simplest terms. So what can go into both? I see 4 can go into both. 36 divided by 4 is 9, and 48 divided by 4 is 12. Am I done? Well, I can see that 3 can go into both of those. So 9 divided by 3 is 3, and 12 divided by 3 is 4. Can I keep going? Nope, that's the smallest one. Now, some people might have seen 12 right off the bat, and they would have gone 36 divided by 12 is 3, 48 divided by 12 is 4. Or if you started with 3, or if you started with 2, as long as you keep going till you can't go anymore, we all should have ended with 3 over 4. And then it said it wanted it in all 3 ways. So 3 to 4, and 3 to 4, but with a colon between it. And there you go. This is 3 to 4 in all 3 ways. Okay, number 17 says the table shows the number of different types of reference books in a library. Write the ratio in 3 different forms of dictionaries to the total number of reference books. Okay, so dictionaries, I see they have 8. And then the total number, well, 8 and 5 is 13, and 13 plus 12 is 25. So they have 25 reference books, and only 8 of those are dictionaries. Can I reduce that? Well, the only numbers that can go into 25 is 5, and 5 can't go into 8. So that's simplest terms. So just write it the other 2 ways. And there you go. Now you have dictionaries to the total amount of books in all 3 forms. Okay, number 18 says a drink mix label states that 2 tablespoons of mix should be added to every 5 cups of water. If a container has 40 cups of water in it, how much mix should be added to the water? Use a proportion to help solve. So for this one, it doesn't matter what you put on top or bottom because you're going to set up a proportion to help you figure it out anyway. So as long as I stay consistent, it doesn't matter. So let's do tablespoons of mix first, and then every 5 cups of water. So it says 2 tablespoons of mix goes with 5 cups of water. So if this is what we have to do to make it taste good, the container has 40 cups of water in it. So where should I put that 40? Well, cups of water is in the bottom, so I'm going to put the 40 here. And then we're trying to figure out how much mix should be added to that amount of water. Okay. You could do cross products. 2 times 40 is equal to 5 times x. So 5x is, well, 2 times 40 is 80. Divide by 5 on both sides to get x by itself, because those cancel. Anything divided by itself is 1. 1 times x is just x. And you do that to get x by itself. You can do that as long as you do the same thing to both sides. And 80 divided by 5 is 16. So you need to add 16 tablespoons of mix, because that's what we were solving for x, right? Yes, this would work. Or you could have done the shortcut, go towards your unknown. Well, 5 times what is 40? 8. So then 2 times 8, that's 16. So 16 tablespoons of mix. Now it's not tablespoons of mix per cups of water, because it's not 16 tablespoons or tablespoons of mix when there's 1 cup of water. It's 16 tablespoons of mix when there's 40 cups of water. So again, your unit is tablespoons of mix. I know that some of us get tripped up by that. So think about what it is you're solving for. You're solving for this, which is talking about just the tablespoons of mix. Okay, number 19. It says a gas pipe company is laying gas pipe through some mountains. Due to the uneven landscape, the workers must lay approximately 6,500 feet of pipe for every 1 mile of land they cover. So we're talking about piping feet to miles. So they're saying that you have to do 6,500 feet of pipe for every 1 mile of land that you cover. So if they have to cover 8 miles, 8 goes on the bottom because that's where the miles are, of land, how many feet of pipe do we need to lay? And we don't know the feet of pipe. That's why that's the unknown. Okay, so go towards your unknown. Can I do that shortcut? Well, yeah, because 1 times what is 8? 8. So do 6,500 times 8. Type that into your calculator for sure. And 6,500 times 8 is 52,000. So that's 52,000 feet of pipe that they're going to have to lay to cover 8 miles of land. Okay, next one, number 20. This is one of those is over of equals percent over 100 problems. Well, I see the percent sign, so that's my percent. That goes over the 100. And then of what number? Well, we don't know the of, so the of is the unknown. And then it says is 91. So 91 is the is. Can you go 91 times something to get 130? I don't know of anything. So let's do cross products. Well, 130 times x is equal to 91 times 100. Well, 91 times 100 is 9100, and set that equal to 130x. To get x by itself, you want to divide both sides by 130. Those cancel, and you get x is 9100 divided by 130, 70. There you go. X is 70. Number 21 says the ratio of oxygen atoms to sulfur atoms and sulfur dioxide is always the same. The table shows numbers of atoms and different quantities of sulfur dioxide. Complete the table. Well, sulfur to oxygen, it says when there's 6 sulfur atoms, there's 12 oxygen atoms. So if there's 9 sulfur, how much oxygen is there, right? Right here. I basically just used the table to help me create a proportion. That's essentially what they are. Can you do 6 times something to get 9? No, so do cross products. Well, 6x equals 9 times 12. 9 times 12 is 108. And if you want to solve for x, you're going to divide both sides by 6. Those cancel, and you get x is 18. Okay, so this number would be 18 right there then. And then, yeah, you could use 9 over 18 equals 21 over x, but just in case we made a mistake on the 18, always use the one that they gave you. So 6 over 12 equals 21 over something. I can't do 6 times something to get 21, so let's do cross products. 6x equals 12 times 21, and 12 times 21 is 252. So to get x by itself, you would divide both sides by 6. Those cancel, and you get 252 divided by 6 is 42. So this number would be 42. And then the last one, your proportion is 6 over 12 equals something on top, but 54 on the bottom. Again, you can't do 12 times something to get 54, so let's do cross products. 12x equals 6 times 54. 6 times 54 is 324. And to get x by itself, you would divide both sides by 12. Oops. 324 divided by 12 is 27. So this last one would be 27 right there. Now, that's one way to do it. Okay, so since they told me this, I can use that to set up proportions for the unknowns. Keep these in the same line and keep these in the same line, because these are all talking about oxygen and these are all talking about sulfur. But another way that I could do this instead is you could find the unit rate. So think if this is 1, what is this? Well, how do you go from 6 to 1? If you divide by 6. So what's 12 divided by 6? 2. So they're all in a 1 to 2 ratio, right? So if you did 1 times something to give you 9, well, it's 1 times 9, right? So then do 2 times 9, you get 18. Okay, and then you did 1 times something to give you 21. Well, 1 times 21 is 21. So do 2 times 21, and that'll give you 42. And then here you did 2 times something to give you 54. Well, 2 times 27 is 54. So 1 times 27 would give you that 27. Because whatever you multiply this by, you have to multiply that by, right? So that's another way we could have completed that table, is find the unit rate first, and then since you did 1 times 9 here, do 2 times 9 there. So these are all going to be multiplied 1 times something. These are all going to be multiplied 2 times something. And 1 times what is 21? 21. So 2 times 21 gave me that 42. 2 times what gives me the 54? 27. So 1 times 27 is that 27. Okay. Now these represent points on a graph. So let's go ahead and graph these. But first of all, I need to know what my graph is counting by. So they went halfway between 0 and 12. What's halfway between 0 and 12? 6. So they're counting by 6s. So that would be 6, 12, 18, 24, 30, 36, 42, 48, 54, and then 60. Okay, so that's this side. And then this side's counting by, well, what's halfway between 0 and 6? 3. So 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. Okay, so this is representing sulfur. So this is your X and this is your Y. So the first point is 6, 12. Then over 9 right here and up 18. Then over 21 up to 42. And over 27 up to 54. Okay, now normally we always connect these to make a line, right? So essentially you want to kind of like lightly draw a line to make sure that they're all in the same pattern, because if one point's like one dot is way off here, then you know that you're not correct, because all these follow a linear pattern, so they should connect to make a straight line. However, these are representing atoms, and atoms are only whole numbers, so you actually don't connect these. They're each represented as just these dots. So I'm not going to connect them because the points in between aren't all included, because like half numbers can't be included. So technically you would erase that straight line. You'd only have the dots for this particular problem because, again, half numbers aren't included. But you do want to make sure that they are within a straight line, like they all line up, and you don't have one falling off the graph. Then you'd want to double check that point in your table or make sure that you graphed it correctly. All right, if you got all of those correct, then you are well on your way to acing this test. You got this, my little mathematicians.